All right, good morning. Well, thanks for coming. Thanks for the organizers to have me here. It's a wonderful day to be here. I want to talk about something that we deal with every single day at work, which is we keep dealing with complexities. And I want to talk about this from the point of view of what I've seen in organizations that I have worked with. I'm a consultant. I travel around the world. I work with different companies. So what I'm going to share with you today are really stories from my observation working with different companies. But before we get started, I want to say when I was a child, I used to tell a lot of scary stories. Now that I've grown up, I just talk about programming. And that is as scary as anything could be. And one of the things they tell us constantly is that the only constant is change. And when I go to companies, they often are interested in telling me that we are agile. And I always tell them, I'm so glad we got that out of the way. Now let's talk about what you actually do. And to me, the most important thing about agile development really is the ability for us to adapt to change. And if we're not able to adapt to change, there is really no point in talking about being agile. And I would say probably the most embarrassing thing for me is a tweet I made when I was actually having lunch with my children. And there's a background thread in my mind, always thinking about programming. As I was having lunch with them, we were talking about something, and suddenly something came to my mind, and I immediately wrote a tweet. And as I was writing it, my children were very curious what I was typing, so leaned over, they looked at it, and the two children were like screaming, "Dad, don't tweet it." Of course, you never follow what your children say. And I tweeted, and this was probably the most popular or unpopular tweet I ever made because I'm kind of embarrassed that it actually got retweeted so many times. And the tweet really said this: I've set the wedding date, I've not asked her out yet. This is how software projects are managed. So if you really think about it, this is our industry, isn't it? There's this guy who walks up to this lady and says, "Sweetie, we're going to get married in June. We're going to have 3 children. Here are their names, and here's where they're going to go to school." And the lady looks at him and said, "Who the hell are you?" And he says, "I'm the traditional project manager." And this is what happens in our projects, isn't it? Everything is set already. The deadline is set, the scope is set, and then they tell us we are agile. And I'm like, what is there to be agile if all that has been set already? But of course, we want to be agile. We want to be able to produce code really fast and be able to adapt to change. But what really makes it hard for us to adapt to these changes? And it turns out that complexity makes it really hard to adapt to change. And the more complex our systems become, the harder it is to really adapt to change in general. So if there's one thing we can do in terms of being agile, it is to keep an eye on the complexity and to be able to reduce it. So from that point of view, I'm going to say system design is complicated by nature. Let's not be naive about it. We're working on systems that are pretty complicated. The tax laws we have to really deal with, the banking rules we have to deal with, all the different cultures and regional laws we have to deal with, all the complexities that come from engineering and science. Well, we can't get rid of them too easily, but those are the things that make our systems really complicated. But unfortunately, though, we take something that's already complicated and then we add complexity to all that. And when we add complexity to what is complicated, it becomes really hard for us to manage in general. So what I want to talk about today is what are some of the ways in which we can identify these complexities and maybe eliminate them or at least alleviate them. Well, we are victims of our own complexity. So a lot of these things we create upon ourselves. There are 2 kinds of complexity we have to deal with every single day. One is called the inherent complexity, and the other is called the accidental complexity. The inherent complexity comes from the problem domain. This is the business domain. This is the application we have to deal with. And we can't get rid of those inherent complexities. We just have to deal with it. But unfortunately, though, the accidental complexity comes from the solutions that we use. And when the solutions bring complexity, what do we normally do? We bring other solutions to manage those complexities. And those solutions in turn bring complexity, and we quickly get drawn into this vicious cycle and becomes really hard for us to deal with. So what makes software system really complex? And I'm going to talk about a few observations I've had over the years. The first one I want to talk about is too many moving parts. And we see this quite often in a lot of applications we deal with. And I'm going to say this only has gotten worse with microservices because we got way too many moving parts in our systems now, and trying to comprehend all the bits and pieces that come together is incredibly difficult. But I'll talk about one particular experience I had with a client of mine that I was working with. Well, Leslie Lamport has this beautiful quote. He says, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. This is so true in the world we live in, especially in the world of cloud computing we live in, and distributed computing. And if you really think about it, when you press that button on your mobile phone, the number of systems that are involved in processing that request is just mind-blowing. It's a miracle that things actually work on the days it actually works. And so there's so many moving parts we have to constantly deal with. But I remember one particular client I was dealing with, and they wanted to really make things extensible. And the desire to make it extensible, they made everything configurable. I mean, when you talk about everything is configurable. And they are in an industry where they have to work with multiple clients. I'm not even kidding with you. When I started looking at their code, literally there was code that said, if it is company 1, do this, company 2, do this, and there's so many different possibilities. But then to make things worse, they had everything that could be configured, and when I asked them how they manage it, they said the team of engineers would spend time configuring the application before they put into production for a particular client. And the amount of time they would need to do this is 4 to 6 months, because this has turned into a monster where everything can be configured. So it's excessive configuration, a lot of components, and way too many layers in this application. But what I then noticed was how they were doing this, and they were configuring this using XML. And of course, XML was a great idea when it came out. And then when you start working with XML, you realize that no human should ever be allowed to touch XML. If at all somebody should be forced to use XML, it should be given to people in the prison. And nobody in the free world should be forced to use it. So I realized that configuring XML is configuration from hell. And then I have a theory about XML as I've started using it. And that is, XML is like human. They're very cute when they are small, but get annoying as they get bigger. And it becomes almost impossible to deal with it. And this particular company had everything in XML, and it was a torture for developers to manage this code. It was becoming extremely hard for them to work with. So sometimes we can get carried away, and in terms of extensibility, we bring in so much complexity that we can't even keep up with this kind of application. It becomes really hard to work with it. So what is the lesson I learned from this is, yes, we want flexibility, we want to be able to configure, we want extensibility, but we cannot afford to go overboard with it, because at some point it becomes really detrimental. We cannot keep up with it. And the application turned out to be extremely brittle, very error prone, very hard to deploy. And this is one of the things I always emphasize teams is, if you're having trouble during development, it's an early warning sign you're going to have trouble during deployment as well. And another thing to really think about is how hard it is to really test the application. And I often tell developers, when somebody tells you this code is hard to test, what they're really telling you is the design of the software sucks. Because that's what it really means, because testability is a reflection of the quality of the design or the lack thereof if it's really hard to test it. And of course, the system is really hard to reason. Well, the next thing I'll talk about here is things I've seen is invisible changes. I'm actually quite angry when I say this. Well, a team contacted me and said, well, Spark, Scala, why don't you help us to implement this code in Spark and Scala? And I shouldn't have said yes. But unfortunately, I was really happy to help. I said yes. And what they sent me was this C++ code. Now, to be honest about this, C++ is a language I actually like. I've spent about 15 years programming in C++. I offered courses on C++ for as much time, if not more. I've kept up with the changes in C++ as well. I know what has happened in C++ 11 and so on, and 14 and so on. So it's a language I know fairly well. And the code they sent me is not a very big code, maybe about 200, 300 lines of code. But what really bothered me was the inability for me to understand what the code was doing. And I realized after that a few things I always think about. There are two kinds of code that really frustrate me. The first is the code that doesn't work. The second one is the one that works but shouldn't. And these are extremely annoying. And you are looking at this code and staring at it thinking, why does this even work? And in this particular case, what they had done was their code, I was reading through it, and I was looking at the constructor. And when I walked into the constructor, the object obviously has not been initialized. And I'm walking through a method called getSomething. And I jump over the method, and suddenly this object is completely populated. And I'm thinking, why would a get method populate an object? And of course, after spending a lot of time not able to understand it, I start stepping through the code. That's called the desperate measure, isn't it? And I'm now stepping through next layer, and that only takes me to the next layer, and the next layer. I'm deep down here, still frustrated, not understanding why this code is actually working the way it did. And eventually I got so frustrated, I emailed them and said, do you have a research paper based on which this code was written? And they're like, oh, of course, and they point me to the research paper. Honestly, I threw the code out, read the research paper, wrote the code, and sent them and said, here you go, it works, and don't ever get back to me. And the point really is, when people write code like this is an insult on the programmers, because the amount of time you have to spend to learn, and this was an invisible change that I really came across, so don't sneak around and change state of objects so the programmers don't know that you're changing the state. So one of the things that we should really do when it comes to writing application and to reduce complexity is to make it very obvious as to what the state transition is to the programmer, so when they read the code, they are familiar with what's going on with it. Otherwise, it becomes a really expensive time on the programmer, and we end up wasting time and money trying to understand the code, and how can we really be agile when we're wasting so much time? Well, the next thing I'll talk about is uncontrolled mutability. And we have dealt with this quite a bit in our work. We create mutable variables, we change them across, but unfortunately, the more mutability we create, the more difficult it is for us to reason with the code. I remember one day a developer come to me and said, hey, I'm looking at this code, can you help me with it? It doesn't work. And we both read the code in front of us. It was not a big code, 20, 30 lines of code. And I said, if this is the input, this should be the output. He said, I know, right? But it doesn't work. So we both are reading it many times. And then after several minutes, I said, wait, did you really mean to change the input given on line number 7? And he stayed for a minute and said, I'm stupid, and he walked away. And this is what happens when we mutate code. We're not able to reason the code properly. In fact, this is one of the things to keep in mind is mutability company, it often hangs around with bugs in code. And oftentimes it increases the errors in the code as well. But I'm going to go to the extent of saying that a state transition causes brain damage. And this is so true because what do you do when you're working with code? You're trying to reason, you're trying to understand the code, and you're trying really hard to work with it. But oftentimes this becomes really hard for us because when we are trying to really make the code to work, it is almost impossible to reason the code and understand how the code is actually working, and that can be really hard. I'm going to change the audio here for a second if you don't mind for me. So usually it messes up, so let me try to change the sound here, so give me a second. So this is the beauty of systems we work with. When you change the systems, it doesn't want to work anymore, so let's see what it's doing. Let's see if that works. There you go, that's better. All right. So that's another complexity we have to deal with. So when it comes to this, I'm going to say this is only programmers can actually understand. When you are programming, you are building all the state in your mind. And you have been staring at this code, and slowly but surely, you're thinking about this object is talking to this other object, but the state is over here. And then suddenly somebody opens the door and says, have you had lunch? And you just stare at them, you're not speaking. And they look at you and say, I'm sorry, have you had lunch? And you're still staring. And they say, you're weird. And they walk away. And only programmers will understand it. And then they come back again and say, are you okay? And you're like, no, I'm not okay. Because when they opened the door and said, have you had lunch? This mental model just fell on the floor. And it's completely shattered. And now you have to put this back to get back into the flow. And that takes several minutes for you, isn't it? And this is something only programmers will really understand. And you know never to interrupt programmers asking these kind of stupid questions. And as a result, this becomes very expensive. But what causes this? Now, I'll tell you, the best money I ever paid in my life was when I went to watch a movie with my wife. Well, talking about my wife, she thought she was marrying me. Then she realized she actually married a programmer. And this was a very hard time for her to understand this in the beginning. But we've gone through several years, been married for a very long time. I'm pretty happy. And I'm very thankful for her to really stay with me for that. But this happened a long time ago when I was, newly married at the time. After spending maybe a year or so, one day she said, hey, I'm going to go shopping. I said, oh, I'll come with you if you can wait for 5 minutes. And she picked up the keys and left. And she came back like 10 minutes later, I think. And then I looked at her and said, I'm really sorry, but I told you that I'll come with you in 5 minutes. I'm a little upset that you left without me. And she put her hands on my shoulder and said, sweetie, I'm going to tell this to you once, and you better listen. When you say 5 minutes, it's 7 hours in human time. And that's when I realized she was right. And this happens to us all, isn't it? When the boss comes to you and says, how's it going? Are you done? You say, almost done. And we do this all the time. We have a completely different perception of time than other human beings do. So when you say 5 minutes, a few weeks later, we're still working on that code. And that's what she made me realize, that we have a completely different perception of time. But still, living with the programmer is a hard life for the entire family. And I'm sure your spouses and your kids and family and everybody around you have realized it. But in my case, years later, I was watching the Social Network movie. And as I was watching that movie, there was one scene when my wife literally screamed and said, oh my gosh, I get it. I'm like, whoa, what did you just get it? And it was this scene. Let's see if I can play this for you. And I could never forget this particular scene in the movie. So it's a scene where Sean Parker is there and the team is working on coding over there.
I didn't know we had a doorbell. Andrew, get the door! No, he's wired in. That's gonna cut into security deposit. Andrew.
Now down.
Good boy. I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
So that's what I'm talking about. When he said he's wired in, my wife is like, I know why you're weird like this when you work, because you're wired in. I'm like, take my money. This is finally working. And a week later, I was in the kitchen coding away when one of my children came and asked me a question. And immediately my wife said, don't talk to daddy, he's here, but he's wired in. And I'm like, awesome. And this is the best ever, because I've come to a realization that happiness is when the world understands programmers. And this is one of the things that you begin to realize, that when you are programming, you're not just sitting there and listening to music. You're deep down thinking about this. You got the state in your mind, and you're wired in. And that state is extremely important. In fact, honestly, because I'm a consultant, I travel a lot. A lot of times I spend my time in coffee shops, namely Starbucks. And I would be sitting in Starbucks, literally working for 6-7 hours. And it's a very noisy environment. And yet, in all this noise, you have a cone of silence around you. And nothing ever bothers you. In fact, I work in these kind of coffee shops so much that my niece actually thinks that I work in a coffee shop. And so anytime somebody says, where's uncle? He's like, he's working in the coffee shop. That's what she says. Well, the point really is that we find our zone no matter where we are, and that's what we programmers do. The next problem really is lack of cohesion. So what is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. And cohesion is where like things are together and dislike things are apart. And for this reason, we want to do this because we want to reduce the cost of change and the frequency of change of the code as well. And as a result, we want to be able to modularize the code and as much as possible build them into smaller modules. And this is something we have learned over the years. When code becomes really large, it becomes really hard to maintain it, and we want to maintain that kind of cohesion in the code as much as we can. But then, of course, we can't really talk about things without talking about dependencies. Now, dependencies are this unfortunate evil. We cannot live without them, but we cannot live with them. And this has gone only worse over the past a few decades. And we constantly have to deal with dependencies. How many dependencies do we have to really deal with? It is kind of scary when you open applications and find out the number of dependencies they actually have. And I'm going to say I've had one hell of a programming career, from DLL hell to jar hell to assembly hell down to NPM hell. What is next? Well, I know what is next in Java. It's called the module hell. And this is, you could work for about 30 years and you just go from one hell to another. In fact, the other day I was on the airplane and the pilot said, "Folks, we have a smooth ride. I'm turning off the seatbelt," he said. I shouldn't have done it, but I was eager to get some work done. So I opened my laptop, and all I did honestly was I typed npm npm install. And the minute I did that, turbulence, he turns on the seatbelt and says, "Please wear your seatbelt." I'm like, "Sorry, I didn't mean to do it." And I never ever run this again on airplanes. And the point is, it goes out with vengeance and installs the entire internet and causes turbulence. And the point really is, how do we deal with these kinds of complexity in the applications? Well, I was working with the client not too long ago, and they were working on a JavaScript project. And I asked this particular client how things are going, and he said, "Well, we quit running our tests recently." I said, "Why would you quit running your tests?" He said, "Because we upgraded a few of our dependencies, and the test quit running, we don't have time to fix it." And then I asked him, "How many dependencies do you have?" And without missing a beat, he said, "Oh, we got about 150 dependencies on this project." I said, "Come on, this is not a big project. Are you serious that you have 150 dependencies?" He opens his build file and shows me, sure enough, there are well over 150 dependencies. And then I asked him, "Why do you have all these dependencies?" And he looks at me and says, "Because we found them." And this is so true, isn't it? You are having lunch with your team, and you hear the people on the next table talk about this XYZ package. And you turn to your team and said, "Have you heard about this XYZ package?" And they're all very remorseful. "No." But 15 minutes after you come back from lunch, it's installed in production. Because that's what we live in today, right? How could you not have another more dependency and package in your systems? I was talking about this npm hell to somebody, and he said, "Oh, I don't have that problem," he said. And I was curious. I said, "How come you don't have that problem? What kind of project do you work on?" And he probably said, "I work on a Java project," he said. And then I asked him, "Well, gosh, that's interesting. How do you deal with dependencies?" And he said, "Oh, that's easy because I use Maven." I had to tell him the bad news. You don't use Maven. Maven uses you. And the point really is that you get sucked in. It beats you down. And it's not the tool, but it's all the dependencies we have to deal with. And it becomes incredibly hard to work with. And then we just suffer and suffocate with all these dependencies that we have to work with. So the more dependencies that we bring in, the harder it is for us to maintain the application. And that definitely has a problem on our agility. It becomes extremely hard for us to keep up with change over time. So the question is, what can we do about these dependencies? And this is one of the things we have to be very careful and be very cautious as developers. I would say this is our professional responsibility as developers in organizations we work in, is to be very careful in managing and governing the dependencies we bring in. Dependencies are often hard to maintain. They become obsolete really quickly, and they become incompatible as well. The next thing I'll talk about here is a technology infatuation. This, I think, is a disease we live in today. Because a lot of programmers get excited about all the shiny new tools. I mean, don't get me wrong. I want to learn new tools constantly. We go to conferences, we go to user groups, we read blogs, and the next thing we think about is, "Oh my gosh, this is awesome. I got to use it." Well, I would ask developers to do two things. One is constantly learn, but apply your learning in creating pet projects. Apply your learning in creating side projects where you can experiment, apply the tools, and learn them. But have the wisdom of not bringing them to your production code until you have a very proven need for that particular technology. And what really gets to a problem is when developers try to use technologies they learn directly on their product without even realizing whether it is the right set of tools for the problem we have. And oftentimes what happens is when these developers implement those solutions, that becomes an accidental complexity when it's not the right choice. But then when they leave, the other team members who take up the project have to suffer with it for months and years to come. And this is something we have to really keep in mind as developers, be sensitive to what we leave behind when we move projects and leave the code behind for other developers to use. So is this technology the right choice is something we have to always ask the question. So if we take the time to learn these technologies on a side project, we can get really competent learning the whys and whats of these technology, but not really drag down the projects we're working on until those technologies are the right choice for those products in production. One of the things I would ask developers to ask the question is reversibility. So what is reversibility? Reversibility is the ability to back out of design decisions and architectural decisions. So if a decision is easy to reverse out, easy to back out, much more easy to make these decisions. But if a decision is really hard to reverse out, it becomes expensive, then I would be really reluctant to apply that. I want to take more time to evaluate it before I actually commit to it. So reversibility is a really good way to think about, whether we should jump in and start using, or maybe ease into it with more due diligence and asking the right questions and evaluating the applicability of certain technologies. And this is one of the places where I want to think about the word library versus the word framework. So think of the word library for a minute. A library is what you use. A framework is what grows around you. I fear frameworks. If you ask me what keeps me awake in the night, it is not the libraries that I have in production, it's the framework that I'm using in production. Because the framework grows around me and locks me in. And as a result, it becomes really hard to reverse out of. Libraries are easy to reverse out of, frameworks are really hard. So the use of library is easier compared to the use of frameworks. So here's a way to really think about the difference between libraries and framework. Now, when it comes to a library, here's a silly analogy I would point, and I would say that a library is like dating. Using a framework is like entering into a marriage. We got to be extremely careful. Because if we take that really lightly, it could hurt us really bad. Maybe you had a bad date and you can walk away from it. That's a library to me. But coming to a library, or a framework rather, is a lot more serious business. Of course, just because we use a library doesn't mean that it's easy to change all the time. One of the things I would ask for is what's called the surface area. So what I mean by surface area is, imagine that here is a library, and if I depend on this library throughout my code, my surface area is really big. So if I decide to remove this library, it is expensive at this point. On the other hand, if I have a library, but if here I have my application here, but I'm going to provide maybe a facade or a proxy or an adapter, whatever you want to call it, but I'm going to make the surface area extremely small. And when I make the surface area really small, when the time comes for me to make a change and replace this library with something else, it's a lot easier for me to change it. So one of the design criteria we should use is, when it comes to using libraries, to minimize the surface area so it becomes a lot more easier to replace. And again, that's a decision we have to make when it comes to reversibility as well. Well, when I was young, there was a time when we did not have the internet, or at least the way we have internet today. There's always a fascinating conversation to have with my children. And they would look at me and really be surprised and say, what do you mean there was no Google when you were young? And then they would ask me, how did you even get out on the street? And they would really think that there was dinosaurs roaming around when I was a kid, because they feel like without internet it was Stone Age or back in time. But back then, we didn't have the luxuries we have today. So if I wanted to use a particular tool or a product or a library or a framework, you got to know about it in trade magazines. We didn't have blogs. We didn't have web browsers back then when I was a kid, a young programmer. And of course, you learn about it in a magazine or you learn about it in a user group. And then, of course, you finally go to your boss, ask for permission to buy it. You place an order by mail. And eventually, one day, this will arrive in your office. And my youth was spent installing things using a tape drive. When there's a tape drive involved between you and the product you want to use, you don't use too many products. I'm not suggesting that those days were better, but I'm suggesting that those days we didn't install as many products because it was so damn difficult to install products. And so we installed very few of them. And when we had to install those products, we actually took the time to evaluate it. Today, products are one click away. And somebody is telling you about a product. Before they finish the sentence, it's downloaded, integrated, and in production. And this is insane world we live in. And before you can think about it, there's 20,000 dependencies and applications. And why do people use so many things? I was recently talking to a developer, and he was telling me he's going to use a particular library in his product. And I said, look, I know your application. I cannot think of a good reason to use this library. And he leaned over and whispered to me and said, Venkat, please do me a favor. Please don't talk about this to my boss. And I said, why not? He said, because we convinced my boss that we cannot do the application without it. And so we have to use this. Then I realized there's a reason why developers do this. There's a technical term for it. This is called resume-driven development. And people want to use products because they can put them on the resume. You know, when I get these resumes, I look at the product list that's listed on, it's dangerous. And I look at them and say, can you use all of them? And they're like, yeah, I ran out of space, I can do more. And then I ask them, would you come to my company and install all these products and make our company worse as well? The point is, I want to get products into production and release and maintain the application. I don't want to complicate it with all these unnecessary dependencies. So when it comes to dependencies, I always ask the question, am I better off with it or am I better off without it? And there's a cost of not using it. But let's not forget there's a cost of using it as well, and we have to be very careful about it quite a bit. So from that point of view, we have to be very careful in evaluating the dependencies we want to bring in. But I'll share with you an unfortunate story, though, that I could never forget. I was working on a project. This was in 2004, when the economy was really bad in the US. And as I was working on this product, we were struggling to really hire really great developers, because sometimes when the economy is bad is when you have trouble hiring them also. And as we were really looking forward to hiring these developers, we found one guy who was incredible. He was amazing. And I was really eager to have the company hire him because I wanted to really work with him. I was selfish. I want to learn from him. So my boss came to me and said, hey, what do you think of this guy? I said, don't waste your time talking to me. Go hire him. We want to develop product with him. I'm going to learn everything I can from him. This guy is amazing. Hire him. And then my boss said, what do you think of the framework he's been developing? I said, that's the best framework I've ever seen. It's amazing. Don't waste your time. Go hire him. Then the third thing he said was, what do you think of us using the framework on our product? I said, well, sit down. Don't even mention it. Don't even bother bringing this topic. Hire the guy. Let us put him to work on the project. Let's get this out of the door. Don't even talk about this framework. Hey, you just said that's the best framework. I said, that's the best car out there. Doesn't mean I have to buy it. So, hey, did you look at this amazing, persistent, distributed, persistent architecture? I said, look, you never use those words in one sentence ever before to me. Why are you doing all of this? Let's not do this. Let's focus on the product. Let's release this. Don't do this. A week goes by, my boss comes to me, sits down on my desk and says, Venkat, I got a great news for you. We decided to hire this guy and he's accepted to join the project. And I said, this is awesome. This is going to be really fun. And then he said, as a part of the contract, we agreed to use this framework. I said, tell me you're kidding. It's like, no, we have decided this. I said, well, in that case, I just turned in my resignation. I'm leaving. And 5 minutes later, I packed my stuff. And he said, I know this was coming. I already told my boss you're going to quit the minute you know this. I said, at least I'm predictable. Thanks for asking. And I left. This is one of the few days I went home early. My wife looked at me and said, hey, you're awfully early today. I said, yes, I quit. And then she said, what does that mean you quit? I said, that means I don't have a job. And she said, in that case, I got dishes for you to do in the kitchen. That's how she is. And a week went by, found something else, moved on. A good year later, a year and a half later, I get the call from this particular person that I worked with, and he said, all right, Venkat, go ahead and say it. I said, what do you mean say it? He said, go ahead and say it. I told you so. I said, I'm sorry, what happened? Well, they had spent 18 months writing code to make this framework work for the application when we didn't need the framework in the first place. So when I went in there, and then they said, can you come and help us fix it? I'm like, no, there's a reason I quit. So sorry, I won't. And good 6 months later, 2 years after I quit, they called me and said, we know you don't want to work on this product. We just want you to come and do an expert report on it, review what we did, write a report, and leave. That's all we want. I said, oh my gosh, you guys are done. Oh yeah, come and take a look at it. And I went in there at 8:30 in the morning, and I sit down, and there was this computer with the application running, and there was a little sample data. I entered the data, and I clicked on the button, a search button. 25 seconds later, the display pops up with the result. I said, look, that took 25 seconds. He said, uh-huh. And I did a profiling. That one click created 1,864 objects. And I looked at him and said, did you see how many objects it created? He said, of course, it's object-oriented. And I'm like, where's the database? He said, don't even bother. It's local here. In production, it's remote. Machine speed, don't bother. This is much faster than anything you'll find in production. And then I asked him, where's the team? And he was a little reluctant. And then I said, come on, tell me where the team is. Apparently, they fired the entire team because the performance was so bad. And then I said, I got a feeling you didn't ask me to come here to write a report. He said, yes, that's correct. Fix it. I'm like, sorry, I'm a mortal human being. I'm not a magician. I want to run out of here. And it's really sad when you see this. So don't build what you can download, and don't download what you really don't need. So just because something is available doesn't mean we have to use it, because there's a really big cost of bringing things in. And if we bring things in that we don't need, we are incurring a bigger expense than we can handle. I've seen projects actually fail because of lack of governance like this. This is technology infatuation. We got to be very careful about it. Otherwise, it becomes really problem. And there's no point in companies going down and products not being released just because we developers were so excited to bring things into projects. Well, the next thing I want to talk about here is accidental complexity. I'm going to say low-level concurrency is an accidental complexity. Well, we look at a problem and said, we can solve this with a pool of threads. Now we end up with a pool of problems in general. And we have to be careful dealing with these things. For example, if I were to take a look at an example code like this, I got a variable called false up here. And I have a little loop given here. And of course, when I run this code, what's going to happen? If I eyeball this code, I would say 2 seconds later, the code terminates. But unfortunately, it doesn't. And the reason it doesn't is this variable is set to false, but it never changes even though I may change it elsewhere. And the reason for that is that the compiler optimizes it, the JIT compiler optimizes it, and this is really hinging on what's called the Java memory model. A lot of developers, me included, have not understood the Java memory model. And when we try to really program concurrency without really knowing it, it is absolutely dangerous. And so a design skill we have to develop is the ability to discern accidental complexity from inherent complexity of applications. And imperative code often has accidental complexity in it. On the other hand, functional style code has reduced complexity. This is one of the reasons I'm a big fan of functional style of programming. And imperative code leads to a lot more harder to understand code, which really is an accidental complexity we have to deal with. But on the other hand, a declarative style really makes it easier for us to understand the code. And the last thing I'll talk about here is called entwinement. And entwinement is a problem that every developer has faced, including the folks who are behind the JDK. They have really faced it as well. So for example, here's a class called resource. Imagine it has some out-of-memory resources, maybe an open file, maybe a web service it's talking to. How do we clean it up? Well, back in the days, we had the finalize method. I'm so happy finalize is deprecated in Java 9. But before Java 9, we were relying on things like finalize. But finalize, well, the memory is cleaned up automatically in Java. But when memory is cleaned up, it's not deterministic. We don't know when it will happen. But as a hook, they gave us the finalize method. That is an example of entwinement. Rich Hickey says, complecting things is the source of complexity. So that is one example of entwinement, is you take two independent ideas that don't belong to each other, and then you put them together, and this results in a disaster. Finalization is a really good example, but we can see several other examples of this in our own experiences. So one of the things I would ask developers often when they sit down to write code is, are you entwining independent ideas together? And if you do, it's going to get very expensive to maintain this code in the long run, and it comes back to bite us. So we talked about a number of things here. We talked about the too many moving parts. We talked about invisible changes that make it really hard. We talked about the uncontrolled mutability. The lack of cohesion is one of the things that affect a lot of what we do, increases complexity of code as well. Having excessive dependencies in applications. Developers being infatuated with technology and keen to drag in those technologies without really asking if it's the right tool for the right job. Dealing with low concurrency. I would argue that low concurrency is like the assembly language of concurrent programming. Not many of us program with assembly languages for a good reason. We leave it to a few people who can handle it, so the rest of us don't have to. Same thing with concurrency as well. The more we deal with it, the harder it is. It should be really left to a few people developing tools, and the rest of us should work up at a higher level of abstraction. Similarly, an imperative style code becomes inherently more complex. If we can refactor the code into a functional style, we're able to reduce the complexity and to keep an eye for entwinement. We should learn to deal with complexity, but have the wisdom to really minimize it. And as much as we can minimize complexity in our applications, we are really promoting agility in our product. So if our desire is to really keep applications adaptable, if our desire is to create applications that can be changed even late in the game, if our desire is to release products quickly, then one of the things we can do is to reduce complexity. And I would beg the developers to think about this. We often are so eager to tell other people that, hey, this is management's problem. I wish they had done this for me. But I would say this is one area where every one of us, the developers, can actually contribute. Because managing complexity is a professional responsibility of every one of us, the developers. And it's not something we can just point fingers and say, if only they had done it for you, because this is our making. We are responsible for it. So I'm going to say a maintainable code is a gift we give ourselves for the future. And the more we can work towards creating a maintainable code by reducing complexity, the much more fun we're going to have developing applications in the future and be able to work on a sustainable product. Hope that was useful. Thank you.